So, so any event in general that is associated with the probability, any event, whether in communication or in any other place, that is generally associated with a probability. Any message or event generally associated with the probability. So now we want to make a relationship. That means what I'm telling, any event that will have some information. So the information present in a particular event is function of probability of the event, function of probability of event. I'm just writing function. Okay, so that function may be log function. Okay, probability may be inverse probability, like that. So just I'm mentioning information in any event depends on the probability of this event. So now straight away we can define when the probability of a particular event is less, that will have more information. Okay, so in the beginning it may be a little difficult to understand. Okay, if the probability is less, I'm telling information is more. See, you can associate this with the normal phenomena. Say, for example, in today newspaper, they are giving statement like this. In one newspaper, they are giving the statement like, tomorrow the sun will rise in east. In one newspaper, they are giving the statement like this, newspaper 1. In another newspaper 2, they are giving the statement like this, tomorrow the sun will rise, instead of in the east, in some other direction, say the sun will rise in the west. So definitely, as compared to the newspaper 1 event, definitely the newspaper 2 event will have more attention, because usually the sun will rise in the east. That everybody will know, everybody knows that. But the newspaper is telling, based on some research or something, is suddenly telling the sun will rise in the west. Then it will have more attention, because it is rarely happening event. It has never occurred. Okay, it is a rarely occurring event. So that means what? Whenever we are giving some event, if that event is having less probability, it will have more attention. That means it will have more information. That means it will have more information. So, okay, if the event is having less probability, it will have more information. Or if the event is having more probability, definitely it will have less information. So in this case, here there is no new information here. Okay, information means it should be new. So here, the statement 1 from the newspaper 1, definitely it will have less reach, okay, because it is a regular event. So it is having less information. And then the newspaper 2 statement will have more attention. That means it will have more information. So with this, you can easily remember always information and the probability is opposite to each other. It is opposite to each other. Then again, later we will be exploiting the use of this property. I'm just telling now the information is just opposite to the probability of occurrence. Later, you will be using this property in source coding, okay, in the better way. Okay, in order to represent our entire information in simpler format with less amount of data, I will be using this kind of properties. So now I will define the actual formula for information. Say information in any symbol is equal to log of 1 by probability. Okay, just I am introducing log function, that's it. But the remaining, if you see, that is 1 by p. If p is less, I is more. Only thing is I'm introducing log function here. Only thing is I'm introducing log function. So information is equal to log base to 1 by p, where p is the probability of occurrence of a particular events. Okay, so usually the unit of this one is bits. Okay, we are in the digital domain, mostly we will have ones and zeros. Okay, so the unit is in the bits. Or otherwise, if you are instead of putting base 2, if you are using base 10, okay, again the unit is hotly or decile. Unit is hotly or decile. Okay, instead of base 2, if I am using base 10, the unit is different, hotly or decile. Or otherwise, I am putting natural logarithm instead of base 2 or base 10. If I am putting natural logarithm or log with base e, then the unit is nat. Okay, so you have to be very clear with all this formula, but mostly you have to remember this formula in general. Okay, all the problems will be solving based on this formula, and the other two formulas maybe directly it may be asked in the exam, very rarely. So information I is equal to log 2 1 by p is the formula for information with respect to the probability of the event. Now, how to find out log base 2 in case if calculator is not allowed? Okay, in case if calculator is not allowed, say I want to find out a log 2 of some number x. Okay, the x can be anything. If x is in terms of power of 2, then it is very easy. Or otherwise, the calculation of the logarithm becomes difficult. So you can write this in terms of like this: log x divided by log 2. Again, here, what should be the base? What should be the base? This is from the basic formula of the logarithm. The base can be anything. Here in this case, base can be anything. Mostly we are very much convenient with base 10. So we can put base 10 also. In reality, it can be anything. Okay, so once if you want to find out log base 2 x, then we have to use this formula. We have to use this formula. Or if x is 2 power, if x is in the order of 2 power, say for example, this is 8. I know 8 can be written like 2 power 3, then directly 3 is the answer. So, but I am using this formula for other cases. Even for the same case, you can use this formula. Same 3, you can get like this, say log 8 base 10. You just put it in the calculator. Then what is log base 10? 3. Definitely, if we take the ratio, definitely it will be. This is 2, okay. Not 3. This is 2. 2. Definitely, you will get answer as a 3. You can check it out later. Good. So we have defined information. Then we'll define the entropy. Okay, entropy. So entropy means average amount of information. Entropy means, otherwise we can write here itself. What is the definition of entropy? Average amount of information per symbol. Average amount of information per symbol. Average amount of information per symbol. Or otherwise, it is the measure of uncertainty. It is the measure of uncertainty. Measure of uncertainty. That means what? More the uncertainty, more will be the information. But anyway, finally, we are finding out the average information. Whenever we have more number of events, say, okay, in a sample space, if we are having more number of events, then each event will have its own probability. Okay, again, each event will have its own information. But finally, what is the average information? For that, we are using the term entropy. Entropy means average amount of information per symbol. Here, one symbol may have high information, other symbol may have low information. But on an average, what is the overall average information? That is the entropy. That is another name for entropy. That is the measure of uncertainty. Sometimes they will give this term also. Another meaning for entropy is the measure of uncertainty. Okay, so more the uncertainty, more the information. So entropy, another name is measure of uncertainty. Okay. So what is the formula H? Entropy formula H is equal to, we know whenever we want to find out average, here this is with respect to the event. So what is the probability of that particular event? Say if there are n number of events. Okay, again I means indicating the particular event. Okay, say event 1, event 2, event 3, event 4, like that. So H is equal to summation Pi log of 1 by Pi is the formula for entropy. Okay, so multiply the probability of a particular event with the log inverse of that inverse value, inverse probability value. Similarly, you do this for all the symbols, okay, all the event. Then finally you add everything. Finally, you will get the average information, average information. So definitely this function will give information of each event. This is the what is the probability of occurrence of the event. Then if you just multiply both and add everything finally, then it will give you the average amount of information. It will give you the average amount of information. So now, again, here in the beginning, see what could be the say I am having two symbols. Okay, in a particular system, I am having two symbol example. I am having two symbols, say S1 and then S2. If I am defining the probability of occurrence of symbol 1 as P, definitely the probability of occurrence of symbol 2, definitely it will be 1 minus P, because total probability is always 1. Okay, so in a particular sample space, for a event 1 or for a symbol 1, the probability of occurrence is P. For a symbol 2, the probability of occurrence is 1 minus P. Now, what is the entropy for this case? What is the entropy for this case? It's very simple. So H is equal to P of log of 1 by P, then 1 minus P of log of 1 by 1 minus P. So now the question here is, in reality, P and 1 minus P can be anything. Say for example, if P is 0.1, then definitely 1 minus P has to be 0.9. Or otherwise, if P is 0.4, 1 minus P will be 0.6. Similarly, you can put any combination. At some point of time, P is 0.5, then 1 minus P is also 0.5. Now the question here is, you can make any combination. For all the combination, you try to find out H. Okay, each H may be different. Okay, because values are different. The distribution of the value is different. Totally it may be 1, but the distribution is different. So you will be getting different H value. Our formula is same. The formula is same. Now the question here is, in which case you will get the maximum entropy? In which case you will get the maximum entropy? That is our aim now. So now I know what is the formula for entropy. Entropy depends on the probability values in straight a manner, and also with the logarithm of inverse probability. Now the question here is, at which condition the entropy will be maximum? Already we know from the basics of mathematics, to find out maxima or minima, I can use formula like differentiation of dH with respect to dP is equal to 0. Once you try to do the differentiation for this equation, then definitely ultimately you'll get the answer for P. The P will become like 1 by 2. Just try to solve this. Okay, so what I'm getting finally, I have taken some equation. I have taken only two symbols. For the two symbols, I have written entropy formula. Then I do not know what could be the value of P. Just I want to calculate the value of P for which H becomes maximum. Then you can use the differentiation formula. Okay, differentiation. When you do the differentiation of the equation to make it equal to 0, again it will give the value that so at that point you will get either maxima or minima. So definitely in this case again it is maxima or minima. Again detailed procedure is available in the mathematics. So definitely you'll get the maxima in this case, that is P is equal to 1 by 2. That means entropy is maximum if the symbols are equiprobable. So what we are understanding here, okay, so P we are telling like 1, that means what? Symbol 1 probability is 1 by 2. Symbol 2 is also having same probability. Symbol 2 is also having same probability. That means entropy is maximum if the symbols are equiprobable. If the symbols are equiprobable. So what is the conclusion from this? Entropy is maximum if symbols are equiprobable. Entropy is maximum if symbols are equiprobable. Symbols are equiprobable. Whenever the symbols are having equiprobable value, you will get the maximum entropy. In all other cases, definitely you will get the entropy less than that maximum value. That is the main observation here. So now, what is the maximum entropy? What is that maximum entropy? Here, it may not be evident, but once if I put the values, see, H is equal to P log of 1 by P, then 1 minus P log of 1 by P. 2 of log of 1 by 2, 1 minus 1 by 2, log of 1 by 1 by 2. Okay, and finally, you'll get answer here. In this case, you'll get answer, sorry, here 1 by 2. Okay, 1 by 2. So, finally, you'll get answer like 1. So, what is the maximum value possible here? 1. And then for this, there is another formula. Directly, you can get that maximum value. Here, we are deriving for maximum value. Once if we carefully observe, log base 2, I can put m, where m is indicating number of symbols. Where m is indicating number of symbols. Okay, if you directly put how many number of symbols are there, then directly you'll get the what is the maximum entropy. Directly you can get the maximum entropy for that case. Okay, for that case. Suppose if there are 3 symbols, okay, somebody comes and they are saying if there are 3 symbols, S1, S2, and then S3, okay, what is the maximum entropy possible? What is the maximum entropy possible? So you have to directly put that number of symbols. Okay, wherever m is there, you just put the number of symbols, then directly you can get the maximum entropy. Okay, so H max is equal to log 2 m, where m is the number of symbols. M means number of symbols or number of events. M is the number of symbols. So now we started with the information, then we have defined H, average amount of information.